now by transforming this heap into a more visual representation. We're asked to run heap sort with the same question as before. So like the first thing to do is to actually just write it in its heap form. We can do this with a level order traversal, also known as like breadth first search of a tree, if you remember tree traversals when we talked about those earlier in the class. And we can see that 4 would be like the root node, then we have 2, then we have 1, then we have 7, then we have 3, then we have 6, then we have 0. Exactly as how you read it here is how you put it in the trees, in the heap specifically. You go level by level, left to right. Now that we have this heap visual, let's actually start the bottom-up heapification process. So we want to make this a valid heap. And if you recall, with heap sort, we always use a max heap. So since this is a max heap, we can start out by heapifying it bottom up. So we always start right to left, and we go up each level with bottom up heapification. So all of these trivially, like, you sink them down, nothing is really going to happen here because they are leaf nodes. But when we're going to see something happen will always be like this subheap. And in this subheap, remember, it's a max heap. For heap sort, we always want to use a max heap. This node needs to be greater than both of its children. But while it is greater than 0, it's not greater than 6. So we are going to have to swap 1 and 6. And this is actually going to be our first swap. So I'll initialize my swap count to be equal to 1. And now let's look at the array. The array representation of this would be 4, 2, 6, 7, 3, 1, 0. And you'll notice that now, even though 7 was before 6, 6 is now after 7. 7 is now after 6, even though 7 was before 6 originally. So now we'll see that since 6 went in front of 7, with one swap will be our answer.